now we're looking at how do you recognize undefined cases. So the very first thing that I saw that you had written down today was something like you had two matrices, and I don't know what was in there, but what were the dimensions of each matrix?
There was one that kind
So
of...
what are the dimensions of this one?
Like this one, and there was one that was like...
You just hear computer, then you go to...
So here, let's look at these.
Okay.
What are how many rows does
Two.
2 rows? 1, 2. Right? So this matrix is 2 by how many columns?
3.
3 columns. This matrix here, how many rows?
2 by 3.
Okay, so a really easy way to recognize that you can't multiply these is red means stop, right? I can't multiply matrices if these two numbers don't match up.
Okay.
Okay, so I'll write out the rule. If I have rows 1 by columns 1 times rows 2 by columns 2, the rule is that I can multiply if these two things are the same. So columns 1 equals rows 2. Okay, and what I get a matrix of size.
Undefined.
No, I get a matrix of size, these two things, rows 1 by columns 2.
Okay.
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 So remember, the intuition behind this was evident in our stores example. Do you remember how we had prices? We had something like store 1, store 2, and then we had prices of masks, shirts, and shoes, right? And we were multiplying this by you and your sister, okay? And you and your sister were each buying a certain number of masks, shirts, and shoes, okay? And what we ended up with, was a matrix with dimensions store 1 and store 2, and then you and your sister.
Okay.
Okay? So look at this. This first matrix was stores. Stores were the rows, and columns were a costume.
Okay.
This matrix, the rows were costume, and the columns were people. Okay? The types of costumes had to match up. The prices for the costumes had to match the types of costumes that you bought.
Okay. Yeah.
And then what we got in the end was a matrix that had stores as the rows and people as the columns.
Okay.
Okay? And I'm just going to do this example out for the video because that way you'll have it on video. Right? We're saying if store 1 costs, we'll say $5 for masks, $6 for shirts, and $10 for shoes. And store 2 costs $7 for masks, $7 for shirts, and $7 for shoes. Right? And you want to buy, what was it, 2 masks, 4 shirts, and 1 shoe. Or I don't even know if I'm messing up masks, shoes, and shirts. But you'll figure it out. It's just a story. So whatever costs $5, you want to buy 2 of them, and your sister wants to buy 3.
Okay.
And whatever costs $6, you want 4 of them. Whatever costs $10, you want 1 of them. Okay. And then here at store 2, everything's $7. The $7 store. Okay.
Not the $1 store, the $7 store.
So again, we'll have you. Oh no. This is now you. So this matrix, how many rows and columns are there?
2.
2 rows.
3 columns.
3 columns. And this matrix?
3 columns.
Be careful.
2 rows. 2
How many rows?
columns.
Rows are
3
like
rows.
stories in a building. How many stories does this building have?
3.
Okay, how many elevators does it have?
2.
Okay, so if you want, it's like
How many
floors,
sides does it have?
floors cross elevators. Okay, so this building has 2 floors and it has 3 elevators. Does that make sense?
Yes.
Okay, this building has 3 floors and it has 2 elevators. All right, so 3 floors, 2 elevators. Remember we said the rule was matrices don't talk to each other unless these numbers match.
They can talk this time. They're
Right.
friendly neighbors.
And conceptually, remember that the reasons why these numbers match is because they both correspond to costumes.
Okay.
So in other words, you want to shop at a store where there are masks, shoes, and shirts,
Yeah.
and this store sells masks, shoes, and shirts. Okay? The output then,
But that doesn't necessarily mean we will shop at that store.
right, this is just information. Matrices are just like a table of information. Okay? So now we know because of our memory of the rules that the output is going to be what by what?
It is going to be
So remember, if the 3 and the 3 talk to each other, they go away. What we're left with is the 2 and the 2.
okay.
And specifically, we're going to have store 1, store 2, and then we'll have you and your sister.
Okay.
In other words, the end matrix that it equals will inherit the columns of this matrix,
Okay.
and it will have the rows of this matrix. Because the rows here represent the first store and the second store, and the columns here represent you and your sister.
Okay.
Agreed?
Yes.
The requirement that they be able to be multiplied is that you want the costumes that they sell.
Okay.
Okay?
As an analogy.
Yes, as an analogy. Okay. And of course, we know the multiplication. 5 times 2, 6 times 4, 10 times 1. You know what? I'm just going to write in the answers because when you're watching this video, you can pause it
Yeah.
and you can do it yourself. Maybe these answers are wrong. We're copying these over from our work before. So, homework. Check.
Okay.
Check these answers. Okay? So just as an overview of everything we talked about for this one. We said that... Are you checking it right now?
Nope.
Oh, you wrote it in the homework. We said you can't multiply these
No.
because 3 is not the same as 2. In other words, this store sells masks, shoes, and shirts, and you only want masks and shirts.
That
Okay?
doesn't make sense. That doesn't make sense as an analogy because it says this store sells masks, shoes, and shirts. Why don't you just go in there and buy masks and shoes?
So what you're telling me then is
Or
what you
you
really
want
need to do.
masks, shoes and shirts.
Ah, so
But the store only has masks and shoes.
so let's
So
deal
you
with
just add
this.
this,
Let's
yeah.
deal with this.
Sure.
Let's say the store has, the store still charges $2, $3, and $5, and then the other store charges $4, $4, and $4, right? And these are masks, shoes, and shirts. Okay, you only want to buy masks and shoes. Let's say you already have the shirt you want to wear. So what do? You take your matrix and you just put zeros down here because you don't want to buy shirts.
Okay.
Does that make sense? Okay. So that's how, like, you can't fix it without sort of doctoring the matrix a little bit. Like, if you just want one mask, one shoe, and your sister wants 2 masks and 3 shoes, and you've already got the shirts, and you want to put this into a computer, you've got to tell the computer that you have this extra row.
Okay.
Does that make sense? All right. Back to, I'm just going to do this zooming thing. I'm going to do an overview. So remember, we need to have these two match up, and then the results correspond to rows and columns. Just like in our example, we had costumes that matched up, and then the rows of the first matrix become the rows of the result, and the columns of the second matrix become the columns of the result. Okay? So, but the shortcut to all this, when you said you don't know how to recognize the cases that weren't compatible, is you just write rows by columns and rows by columns,
Okay.
and you see if these numbers are the same.
All right. The two close numbers.
Right.
Okay.
Well, the columns of the first one, the number of elevators in the first building has to match the number of floors
Okay.
in the second building. I like elevators and floors instead of rows and columns.
Yeah.
Right? Because when you say rows and columns, you can confuse yourself. Right? But nobody ever said an elevator goes side to side. Right? Okay.
No one ever said it won't.
Okay, well maybe. All right. It's an analogy.
Okay.
Don't poke holes. All right?